Hey guys, so in this video, I'm going to continue solving absolute value equations. So I'm going to go into example 2, with the first one being part A. Now, just like what we did before, I'm going to follow these 3 steps. So the first step is to isolate the absolute value function. So that means I need to get the absolute value function by itself. And you can see here that this absolute value function, let me see if I can find a deeper green. There we go. So this absolute value function is not by itself. So that means I need to get rid of that 5 that's outside of it. So to do that, I'm going to divide, if I can get a marker here, divide off 5. Because in this case, since that 5 is sitting out like that, I can assume that it's multiplying that absolute value. So in order to cancel out multiplication, I have to divide. And so here I go. I cancel out the 5s, so that means I have to divide the other side by 5. So now this side here just has the 2x minus 7. And then on this side, 15 divided by 5 is 3. Now, once the absolute value function is by itself, that means you get to split the equation into 2 equations. And when you split the equation, the absolute value goes away. So in this case, I'm going to split. This will be 2x minus 7 equals positive 3, and the other one will be 2x minus 7 equals negative 3. So I've split them. Now all I have to do is step 3, which is to solve for the x or the variable. So I'm going to go ahead and zoom in so that way I can see that just a little bit better. There we go. That's probably better on your guys' eyes. So it looks like in this case, I need to move over the 7 first. It's easier to move the 7 first since I just have to add that over. If I move the 2 first, I have to divide this guy by 2, this guy by 2, and then this guy by 2. So that's a little bit obnoxious. So I'm just going to add over that piece first. So that would cancel. 2x comes down. 3 plus 7 on this side would give me 10. So if I divide this by 2, the 2's cancel. 10 divided by 2 is 5. So in this case, this answer right here is 5. So I'm going to box that in. That way I remember. So that's my first solution. On this one here, I have to do the same thing. I'm going to add both sides by 7. So that cancels. 2x comes down. Negative 3 plus 7 becomes positive 4. And if I divide by 2, x equals 2. 4 divided by 2 is 2. So in this case, my answer here is x equals 5 and x equals 2. And then I am done. All right, let's try another one here. So let's take a look at B. So here's B. And again, this looks like the same problem. Only this time it looks like there's a negative 5 here, but same thing like before, you have to get the absolute value function by itself. So that negative 5 needs to go. So we're going to try to divide it off since it's multiplying. So we're going to divide that off. By the way, this is one of the most common mistakes people do when they first see this problem. They will distribute, I kid you not, people will distribute the negative 5 into the absolute value function. Please do not do that because these absolute value functions do not work like parentheses. You cannot distribute inside of them. You have to get rid of them, okay, by dividing it off. So please do not distribute any number that's outside the absolute value into the inside of it. So once I divide it off, it cancels. That's a highlighter. 2x minus 7 comes down. And 15 divided by negative 5 is negative 3. Wait a minute, that side's negative 3? I thought absolute value functions always produce a positive number, right? So here's the thing you need to watch out for. Anytime you have a negative number outside of an absolute value function, so this is the absolute value, we've already isolated, but it equals a negative value. And that doesn't happen. Absolute values, we've said in the definitions that absolute values only give you positive numbers. So I'm just going to make a quick note of that so that way we can remember. So absolute values don't give negative values or negative numbers. So if you see that, that means that this here has no solutions, or there's no answers that satisfy this because you can't ever get a negative number. So we're done. That was easy. Okay, let's try a little bit of a beefier one here. So this one has a lot of stuff going on. So first off, it's pretty clear that this absolute value is not by itself, right? There is a 2 on the outside and a -7, which we both have to get rid of. But the question is, which one do you get rid of first? Well, in this case, how I determine it is whichever's further away or the easiest to remove. So the thing that's this absolute value function, the 2 is right next to the absolute value function. So this is not the furthest number away. The furthest number away is the 7 in this case. Plus, it's easier to add over the 7 first than it is to divide over the 2. So I'm going to add 7 to both sides. So that will cancel. 2, I keep grabbing the highlighter, 3x minus 1 drops down. The 7 already is gone. And on this side here, 5 plus 7 is 12. Now, I still need to get rid of the 2, so now I can do that. So I'm going to divide off the 2. So that would cancel. So now I have the absolute value function. So 12 divided by 2 is 6, and now the absolute value function is isolated, so now I can split that up into 2. So I'm going to have a 3x minus 1 equals positive 6, and a 3x minus 1 equals negative 6. So because this was a positive number, I can go ahead and split that up. If that had a negative 6, I would just stop right there and be like, nope, can't solve it. It's a no solution. But I can solve this one, so I'm going to go ahead and try to solve for x by adding 1 over. Then I would have a 3x that drops down. 6 plus 1 is 7. Divide by 3. Okay, so 3 doesn't divide into 7 evenly, so you can either write a decimal or I'm just going to keep it as a fraction. Personally, if I have a fraction, I'm okay with that. I might reduce it, but 7 over 3 does not reduce. So in this case, I'll just keep it that way. That's fine. On this side, I'm going to do the exact same thing. I'm going to try to solve for x, so I need to add over the 1 first. I have a 3x equals negative 6 plus 1 is negative 5. I'm going to divide over the 3, and then x equals negative 5 divided by 3, and that also doesn't reduce, so I'll just keep my answer like that. So we just have some fractions with this answer here, and that's perfectly fine. All right, last problem here is D. D is the weird one. It has an x squared. And this one you won't see very often, so I thought I'd just throw it in here for a challenge. But when you have this case, notice that it is already isolated, so you don't have to move anything outside of the absolute value function, which is nice. So you can go ahead and split that up into 2. So you would have x squared equals 36, and x squared equals negative 36. But here's the thing I want us to know. Whenever you have a number that's squared, let's just think about it. So here to the side, if I had a number like 3 and I were to square it, I would get 9, right? But if I have a negative number, negative 3 squared, and I were to square it, that's like saying negative 3 times negative 3, which is also positive 9. So what I'm saying is anytime you have a negative number and you square it, you get a positive number. So in this case, there is no such thing as a negative number when you square it. So if I were to square this x, I should always have a positive number. So in this case, this is false. There's no need to solve for it because this is not true. Because all squared numbers give out a positive number. So the nice part is I just have to focus on solving this equation here. So this is saying what two numbers, when you multiply, gives you 36. So what two exact same numbers when you multiply gives you 36. Or what number when you square gives you 36. If you don't know how to solve this, what you do is you just take the square root of both sides because square roots cancel out the exponent, the square. So in this case, the x drops down. The square root of 36 is 6. But here's the thing. The square root of 36 is also negative 6. Anytime you take a square root, you have a positive and the negative number. Because here, I'll prove it to you. If you take negative 6 and you square it, that's like saying negative 6 times negative 6, which is 36, which is the same answer here. So anytime you take a square root, you have the positive and the negative number. So in this case, these are both my answers. Also, a lot of people will write this as x equals plus or minus 6, and that's another way you can describe a positive and a negative number, is to use that plus and minus symbol. So some people, once we get further into the semester, you'll see me write this more often than you'll see me write the two separately. And that's it for this video. So down below this journal, there are some extra problems that you can work on. On the completed notes, I have the answers listed there, but I don't have them fully worked out. So if you want to see them fully worked out, please come to the Zoom class, and we will work out those problems together.